Hello everyone, today we are embarking on a journey 440 light-years beyond our solar system to unlock the secrets of the most massive confirmed planet humanity has ever discovered. ROXs 42Bb, cosmic behemoth that tips the scales at 9 times. Mass of Jupiter, the king of our own planetary neighborhood. For generations, we've looked to Jupiter as the ultimate example of a gas giant, a world so large it could swallow every other planet in the solar system and still have room to spare. But today, we're leaving our cosmic comfort zone to meet a world that makes Jupiter look small. A world that sits right at the blurry, thrilling boundary between what we call a planet and what astronomers label a failed star or brown dwarf. This is not just a story about a single exoplanet. It is a story about how we define planets, how they form, and just how extreme nature can get when building worlds across the Milky Way. Let us start with the basics to put this giant into perspective. Jupiter has a mass of roughly 1.9 multiplied by 10 squared kilograms, more than twice the mass of all other solar system planets combined. Now imagine 9 Jupiters smashed together into one single, dense, fiery world, that is, ROXs 42Bb. This isn't just a bigger version of Jupiter. It is a completely different class of planetary object, one that challenges every textbook definition we've relied on for centuries. Before we dive into its mind-bending characteristics, let us talk about how we even found this distant giant, because discovering a planet 440 light-years away is no small feat. Unlike most exoplanets, which we detect indirectly through wobbles or dips in starlight, ROXs 42Bb was one of the rare few that astronomers captured in a direct image. In October 2013, 2 separate teams of scientists, one led by Thane Curry from the University of Toronto, and another by Adam Krauss from the University of Texas at Austin, announced the discovery using some of the most powerful telescopes on Earth, the W.M. Keck telescope, the Very Large Telescope in Chile, and the Subaru telescope in Hawaii. These tools use adaptive optics to cut through Earth's atmosphere and coronagraphs to block the blinding light of host stars, allowing us to see faint, distant worlds that would otherwise be invisible. This discovery didn't just give us a new planet. It gave us a window into the earliest stages of planetary formation. ROXs 42Bb is part of the Rho Ophiuchi cloud complex, a stellar nursery filled with young stars and forming planets barely 1 to 5 million years old. To put that in context, our solar system is 4.6 billion years old, meaning ROXs 42Bb is a cosmic newborn, still glowing with the heat of its own creation. That youth explains many of its wildest traits. Its surface temperature hovers around 2240 Kelvin, or roughly 3570 degrees Fahrenheit, hot enough to melt iron and glow with a deep, fiery red hue. Unlike Jupiter, which has cooled and contracted over billions of years, ROXs 42Bb is still puffed up by residual heat, giving it a radius about 2.5 times that of Jupiter. It is a giant, in both mass and size, a rare combination that makes it unique among the thousands of exoplanets we've catalogued. Now let us talk about its home system, because ROXs 42Bb doesn't orbit a single star like Earth or Jupiter. It orbits a binary M-type star system called ROXs 42b. M-type stars, or red dwarfs, are the most common stars in the Milky Way, small, dim, and long-lived. The 2 stars in this system orbit each other closely, while ROXs 42Bb circles the pair from a mind-blowing distance of about 150 astronomical units, or AU. 1 AU is the distance from Earth to the Sun, so this planet is 150 times farther from its stars than we are from ours. For comparison, Pluto is just 39 AU from the Sun, making ROXs 42Bb's orbit one of the widest ever observed for a planetary mass object. This extreme distance means it takes nearly 2,000 Earth years to complete a single orbit around its host stars. Imagine a year that lasts 2 millennia seasons that stretch across entire human civilizations. This wide orbit also tells us a lot about how it formed, because planets this far out can't form the same way Jupiter did through core accretion, the slow process of rock and ice clumping together to build a solid core before capturing gas. Instead, ROXs 42Bb likely formed through gravitational instability, where a dense clump of gas and dust in the protoplanetary disk collapsed directly under its own weight, skipping the slow core building phase entirely. This is the same process that forms stars, which is why ROXs 42Bb walks the line between planet and star. This brings us to the most fascinating question about ROXs 42Bb. Is it really a planet, or is it a brown dwarf? often called a failed star. Brown dwarfs are objects too massive to be planets, but not massive enough to ignite hydrogen fusion in their cores and shine like true stars. The widely accepted boundary between planets and brown dwarfs is the deuterium burning limit, about 13 times the mass of Jupiter. Objects above this limit can fuse deuterium, a heavy form of hydrogen, while those below cannot. ROXs 42Bb sits at 9 Jupiter masses, firmly below that limit, so technically it is a planet. But its formation process, its size, and its heat make it feel like something in between. It is a cosmic middle child, challenging our labels and forcing us to rethink what a planet can be. This is why ROXs 42Bb is so important to astronomers. It's not just a record breaker. It is a test subject for the laws of planetary formation and evolution. Let us compare it to other giant exoplanets to highlight just how special it is. We've found many hot Jupiters, gas giants, that orbit close to their stars, bloated by stellar heat, but these are often less massive than Jupiter and much older. We've found other wide-orbit giants, like those around HR 8799 and Beta Pictoris, but none match ROXs 42Bb's combination of extreme mass and youthful inflation. Its atmosphere is thick with clouds of dust and mineral grains, giving it a deep red color that stands out in direct images. Astronomers have studied its spectrum to learn about its composition, finding signs of water vapor, methane, and other molecules common in gas giant atmospheres, but in extreme quantities due to its high temperature and mass. Every observation of ROXs 42Bb adds a new piece to the puzzle of how giant planets form and evolve, especially in the chaotic environment of young binary star systems. Think about what this discovery means for our understanding of the universe. For centuries, we thought our solar system was the blueprint for all planetary systems, small, rocky planets, close to the star giant, gas planets, far out, and a clear line between planets and stars. But exoplanet discoveries like ROXs 42Bb have shattered that blueprint. We now know planets can be more massive than we ever imagined, orbit 2 stars instead of one form, in ways we once thought impossible, and exist in a gray area between planet and star. ROXs 42Bb is a reminder that the universe is far more creative and diverse than our limited earthbound intuition can grasp. It is a reminder that every time we think we figured out the rules of cosmic construction, nature throws us a giant, fiery curveball 440 light-years away. This giant planet also teaches us about the limits of planetary size and mass. How big can a planet get before it becomes a star? What happens to a planet's atmosphere when it is 9 times more massive than Jupiter and still glowing from formation? How do wide-orbit giants interact with their binary star hosts? These are the questions that drive modern astronomy, and ROXs 42Bb is at the center of them all. The James Webb Space Telescope, our most powerful space observatory, has targeted ROXs 42Bb for detailed studies, peering deeper into its atmosphere than ever before, to map its clouds, measure its winds, and unlock its chemical secrets. These observations will not only teach us about this one giant world, but will also help us understand the earliest days of our own Jupiter and the formation of gas giants across the galaxy. As we wrap up our journey to ROXs 42Bb, let us take a moment to marvel at what we've found. A planet 9 times the mass of Jupiter, glowing with the heat of its birth, orbiting 2 stars 440 light-years away, forming in a way that blurs the line between planet and star. This is the magic of space exploration. We point our telescopes at a tiny pinprick of light in the sky, and we discover a world that rewrites our textbooks, expands our imagination, and fills us with cosmic awe. ROXs 42Bb isn't just the largest known planet. It is a symbol of how much we still have to learn about the universe. Every day, new telescopes, new missions, and new discoveries push the boundaries of what we know, revealing worlds more extreme, more beautiful, and more mysterious than we ever dreamed. We live in a golden age of astronomy, where we can study planets around other stars, map the edges of black holes, and peer back to the dawn of time. ROXs 42Bb is one of the brightest gems in this age of discovery, a giant reminder that the universe is full of wonders waiting to be found. Whether you're a lifelong space enthusiast or just starting to look up at the stars, this colossal world shows us that the cosmos is full of surprises, and the biggest discoveries are still ahead of us. As we continue to explore the depths of space, we'll find more giants, more oddities, and more worlds that challenge our understanding, each one bringing us closer to answering the biggest questions of all. How did we get here? Are we alone? And what else is out there in the vast infinite cosmos? Please like, comment, share and subscribe to the channel.